Hello students, today we are going to discuss magnetic field problems. The vector form of Biot-Savart law is dB vector equal to K ideal vector cross R vector upon RQ. This is the correct form because according to Biot-Savart law, if this is current element, this is observation point, then the magnetic field is written like this. So out of four choice, the correct answer is option 2. The resulting magnetic field at the point O due to the current carrying wire shown in the figure. Due to this wire, the observation point is along the wire, so magnetic field is 0, and due to this wire, magnetic field will be downward, and due to this wire also magnetic field will be downward, and due to this wire also magnetic field will be downward. Because how to determine the direction? Keep the right hand thumb in the direction of current and fingers in the direction of observation point, then the direction outward normal to the palm indicates the direction of magnetic field. So here magnetic field will point vertically downward. So out of four choice, the correct answer is option 2 is the correct answer. Okay. Two insulated wires of infinite length are lying mutually at right angles to each other. In this question, plane should also be same. As shown in the figure, current of 2 ampere and 1.5 ampere respectively are flowing in them. Then the value of magnetic induction means magnetic field intensity at point P will be. The magnetic field due to infinite long wire is mu 0 I upon 2 pi r. So at point P, value of mu 0 upon 2 pi is 2 into 10 power minus 7 Weber upon meter square or Tesla or Newton ampere meter. So resultant magnetic field, because it is downward, mu 0 upon 2 pi I upon r, I1 2 upon 4 plus 1.5 upon 3, and centimeter we convert into meter. This is 10 power 2. So mu 0 upon 2 pi is 2 into 10 power minus 7. This is 1 upon 2 plus 1 upon 2 means 1 into 10 power 2. So correct answer will be 2 into 10 power minus 5 Newton upon ampere meter. So out of four choice, the correct answer is option 2. A wire loop PQRSP is constructed by joining two semicircular coils of radii R1 and R2 respectively as shown in the figure. Current is flowing in the loop. The magnetic induction at point O will be. Dear student, due to SR and QP, magnetic field will be 0, and due to circular arc, magnetic field is written as mu 0 upon 4 pi I phi upon R. Phi is the angle subtended at the center, that is pi. So, and B proportional 1 upon R. So, magnetic field due to R1 will be more. So, magnetic field in case of semicircular wire, magnetic field will be curl the right hand fingers in the direction of current. Okay, then the magnetic field, if the current is flowing in anti-clockwise direction, magnetic field will be perpendicular plane of paper. Okay, so magnetic field will be outward. Okay, and how much will be the magnetic field? Mu 0 I upon 4, 1 upon R1 minus 1 upon R2. This will be the answer. So out of four choice, the correct answer is option 1, because magnetic field due to arc, when current is anti-clockwise and angle is phi, mu equal to mu 0 upon 4 pi I phi upon R in upward direction. Okay, so out of four choice, the correct answer is option 1. In a solenoid, the magnetic induction produced due to current B is a function of distance r from one end. Inside long solenoid, magnetic field remains constant. At the extreme end, B equal to mu 0 Ni upon 2. So out of four choice, the correct answer is option 4. Total number of turns in a toroid is capital N and radius is r. If current I is passed through it, then the magnetic field inside the toroid will be. When the solenoid is closed, both the ends are closed, then it becomes toroid. A closed solenoid is called toroid. Okay, and inside toroid, magnetic field is B equal to mu 0 Ni and N equal to N upon 2 pi r. So dear student, out of four choice, the correct answer is option 3. Option 3 is the correct answer. There is a magnetic field acting in a plane downward perpendicular to sheet of paper. Particles in vacuum move in the plane of paper from left to right. The path indicated by an arrow could be traveled by. Dear student, while calculating the direction of force, what we do? We keep the thumb in the direction of motion of particle and fingers in the direction of magnetic field. Here in this question, magnetic field acting in downward direction. Okay, so you can see from here, if we keep the thumb in the direction of motion and fingers in the direction of magnetic field, then the direction outward normal to the palm indicates the direction of force on the positive charge particle. If the positive charge particle could have been there, it could have been moving, drifted in leftward direction, but it is drifting in rightward direction, so this is negative charge particle. So out of 4 choice, the correct answer is electron. So option 3 is the correct choice. A charged particle having kinetic energy K enters into the region of a uniform magnetic field between two plates P and Q as shown in figure. The charged particle just misses, this word is important, just misses hitting the plate Q, means R equal to D. The magnetic field in the region between the plates, between the two plates. Dear student, whenever charged particle move perpendicular to the magnetic field, path is circular, R equal to mv upon qb, and mv can be written as under root 2mk, where k is the kinetic energy. And in this case, R should be equal to D. So we can find what is D? D equal to under root 2mk upon B equal to under root 2mk upon qd. Okay. So out of 4 choice, the correct answer is option 4. Option 4 is the correct answer. Figure shows a wire of arbitrary shape carrying a current I between points A and B. The length of the wire is L and straight distance between points A and B is D. The wire lies in a plane at right angles to Z, uniform magnetic field B. The force on the curve is, whenever current carrying conductor is kept in external magnetic field, force is given by I dl cross B, where dl is the distance vector, that is the shortest distance. In this case, shortest distance is given D. So the magnetic field will be only I, magnetic force will be I, D and B. Okay. So out of 4 choice, the correct answer I is written as small I in the question. The answer is IDB. Out of 4 choice, the correct answer is option 2. A circular loop carrying current I is placed in a uniform magnetic induction field B as shown in figure. The force on circular loop is, this is general concept, whenever any current carrying loop is kept in uniform magnetic field, then magnetic force experienced by the loop remains equal to 0. So out of 4 choice, the correct answer is option 3 is the correct answer. Magnetic field at point P due to both infinite long current carrying wire is, due to infinite long wire, magnetic field is mu 0 I upon 2 pi r. Now let's solve. Magnetic field at point P, mu 0 I upon 2 pi r. This is 5 upon 7.5 plus 2.5 upon 2.5. After solving this, mu 0 upon 2 pi is 2 into 10 power minus 7. 5 upon 7.5, this is 1.5. 1 upon 1.5 plus 1. After solving this, we will get 2 into 10 power minus 7. This is 1 plus 1.5, this is 1.5. So this becomes 2 into 10 power minus 7 into 2.5 upon 1.5. After solving this, we will get 3 into 5. So 10 upon 3 into 10 power minus 7. But it is not in, answer is in mu 0 upon term. Okay. So the answer should be mu 0 upon 2 pi. How much is there inside? This is 2.5 upon 1.5. Okay. So 5 upon 3. means 5 mu 0 upon 6 pi, and the field should be downward, 5 mu 0 upon 6 pi. So out of 4, this is also very important direction, okay, because 5 mu 0 upon 6 pi are given 2 times, okay. Direction will be downward. Keep right hand thumb in the direction of current, fingers in the direction of observation point, palm direction outward normal to the palm indicates direction of magnetic field, okay. So here at point P, magnetic field will be acting in downward direction. So out of 4 choice, the correct answer is option 2. Magnetic field at origin O due to given current distribution is, dear student, whenever observation point remains located along wire, then magnetic field remains zero. Due to this wire, magnetic field will be zero. Due to this wire also, magnetic field will be zero. And due to this wire, magnetic field will be upward. And due to this wire also, magnetic field will be upward. Okay, and both the wires are semi-infinite. Okay, mu 0 I upon 4 pi r. 4 pi r means 4 pi d. So mu 0 I upon 2 pi d acting in upward direction. So answer will become mu 0 I upon 2 pi d. Out of 4 choice, the correct answer is option 1. Two infinite length wires carries equal current and placed along x and y axis respectively, at which point the resultant magnetic field is zero. Dear student, direction of magnetic field due to straight current carrying wire is given as, keep the right hand thumb in the direction of current, fingers in the direction of observation point, then the direction outward normal to the palm indicates direction of magnetic field. For making magnetic field should be zero, then magnetic field should be cancelled, okay, due to two wire. Now see at point A, magnetic field due to this wire will be in downward direction, and due to this wire magnetic will be in upward. So at point A, magnet will be zero. At point C, magnetic field due to this wire along x axis in downward direction, along y axis magnetic field is in upward direction. So at point A and C, magnetic field is zero, okay. So dear student, out of 4 choice, the correct choice is option 3. Magnetic field at point P due to following current distribution is, dear student, magnetic field due to infinite long wire is mu 0 I upon 2 pi r, and direction, keep the right hand thumb in the direction of current and fingers in the direction of observation point, direction outward normal to the palm indicates direction of magnetic field, okay. So magnetic field due to this wire at this point will be perpendicular, okay. Let us, this is B1, and B1 equal to how much? This is mu 0 I upon 2 pi r, and here current is downward, so magnetic field will be here. Magnitude will be same. This is also mu 0 I upon 2 pi r. If this angle is theta, this is also theta, because this is 90 minus. This angle is theta, this is 90 minus theta, this is theta, this is 90 minus theta. This is theta, this is 90 minus theta, this is theta, this is 90 minus theta. So what is B1? Cos 90 minus theta. So resultant field is 2B1 sin theta. 2B1 is what? Mu 0 I upon 2 pi r. And sin theta is what? A upon r. So mu 0 I upon mu 0 I a upon pi r square, because here 2 will get cancelled. So out of theta 90 minus theta, theta 90 minus theta. Out of 4 choice, the correct answer is option 2. So dear student, option 2 is the correct answer. Two identical coils of radii r and number of turns and both are placed concentrically and their planes are perpendicular to each other, means magnetic field will be perpendicular, okay. Current in the both the coils is I and root 3I. The magnetic field intensity at the center of the coil, circular coil, equal to mu 0 Ni upon 2R. This is like this. Here current is I, here current is I root 3. So magnetic field is mu 0 Ni, mu 0 Ni upon 2R under root 1 square plus under root 3 square. Under root 3 means 3 square, 3 plus 1 4, 4 means 2. So 2 will get cancelled. So mu 0 Ni upon R. So out of 4 choice, the correct choice is option 2. So option 2 is the correct answer.